Attempting to force a single monolithic AI model to execute a massive multi-step enterprise workflow is a reliable way to make the system shatter. Many product managers view AI as an all-in-one solution, but history shows that generalized tools often struggle with specialized tasks. Early consumer electronics tried to combine phones, cameras, and personal organizers into single, clunky devices that failed because they couldn't perform any one function at a professional level. When a single model is pushed to handle complex, multi-stage logic, the technical output begins to degrade. It enters hallucination loops, loses the thread of long context windows, and fails to maintain logical consistency across a deep workflow. The alternative is a multi-agent system. This architecture uses a coordinated team of specialized AI models, each designed to excel at one specific part of the problem. This complexity changes the PM's daily focus. When the product is built on a network of models, your success depends on designing the communication protocols and logic that allow these separate intelligences to function as a unified team. A multi-agent system functions as a network of specialized roles. A researcher gathers data, a writer drafts, and a critic reviews. This mirrors a product manager. Leading from the intersection of business, tech, and design, you guide a diverse team without formal authority. Just as a PM doesn't write the production code for their engineering team, an AI product manager doesn't need to build the underlying neural networks. Your job is to provide the vision and roadmap that these specialized agents need to execute. Consider a B2B product that automates legal compliance. You would design a handoff where an extraction agent identifies clauses in a contract, then passes that specific data to an analysis agent that checks them against current regulations. A multi-agent system is essentially a software-based cross-functional team. The skills you already use to align human teams, setting goals and defining requirements, are the exact tools needed to build these systems. Managing these agents requires a structured design framework. To organize the interactions for our legal compliance tool, we can apply a method like circles. First, you identify the customer's need. In legal work, accuracy is more valuable than speed. Following the framework, you list your agents, but you also include an auditor agent specifically to catch hallucinations before the user sees them. Then, you evaluate the trade-offs. The auditor increases the accuracy the customer demands, but it also adds compute costs, system latency, and higher API usage to the final product. This roadmap for strategic product management highlights the PM's responsibility in the strategy and business plan blocks. In a multi-agent ecosystem, your primary task is to define what game the system is playing and how the individual agents should keep score. You are no longer just evaluating a single AI's output. You are designing the workflow logic that governs how multiple intelligences interact. The most significant risk is treating these systems as a black box. Without clear functional boundaries, the agents can enter unpredictable states. Without strict guardrails, autonomous agents can fall into infinite feedback loops or produce a quality drift, where the final output degrades with every successive step in the chain. To prevent this, you must design human-in-the-loop checkpoints. These are intentional moments where the system pauses. These pauses act as strict approval gates. The agents present their findings or drafts to a human user, who must authorize the work before the system proceeds to the next phase. In enterprise software, total autonomy is often a huge liability. Your job is to weave human oversight into the workflow, maintaining safety and user trust. Troubleshooting these systems requires a change in perspective. You can adapt journey mapping techniques, but instead of mapping human movements, you track the flow of data as it passes between agents. This mapping allows you to perform precise root cause analysis. When the system produces an error, you can use the 5 whys technique to trace the data back through the network and find exactly which agent failed. This modularity is a massive advantage. Once you find the source of the error, you can swap out that specific agent's underlying model without having to rebuild the entire product. The core of the product management role remains intact. You are still the advocate for the customer and the translator of their needs. The only change is that you are now leading a team of specialized AI entities. Move beyond the limitations of isolated AI features. The path to building complex, reliable AI products lies in orchestrating multi-agent systems.
Thanks for watching. Subscribe and like.